Hello everyone, this is PRIYA from R.M.D.E.C Engineering College. In this lecture, we will be seeing about bounded buffer problem. So in synchronization, we are having four classical problems of synchronization. That is bounded buffer, a reader's writer, dining philosopher, and barbershop problem. So in this lecture, we will be particularly concentrating on bounded buffer problem. So the constraint or the problem about bounded buffer problem is you are going to have a buffer of n slots. So this one particular box is called a one single buffer which can hold up to 1 unit of data. So you are going to have number of slots like this. The thing is you are going to have two things. One is a producer, the other one is a consumer. Producer is the one which is going to insert the data inside the buffer, and consumer is the one which is going to remove the data from the buffer. So the constraint here is the producer can insert the data one and only if at least one buffer is empty. So if there is an empty slot, the producer can insert the data. And the constraint for consumer is at least one buffer is full, the consumer can retrieve or remove the data from the buffer. So if the buffer is empty, consumer cannot remove data from the buffer. And similarly, if the buffer is empty, the buffer is full, the producer cannot insert the data inside the buffer. So these are the constraints. The other one important constraint is producer and consumer should not work at the same time. If producer is working on a data, it is going to insert some data. Consumer should not work parallelly. Similarly, if consumer is removing some data, at the same time producer should not insert any data. So this is the overall constraint of bounded buffer problem. So now for this problem, you are going to create a solution using certain semaphores. So whatever may be the classical problems in synchronization, you will be framing the solution using the semaphores. So here the semaphores you are using is mutex, empty and full. In case of semaphores, we will be having two types of semaphores. The first one is binary semaphore, the other one is counting semaphore. So here the mutex or M is the binary semaphore, the other two empty and full is the counting semaphore. Counting semaphore is nothing but which is going to have certain count or integer values. So now mutex is nothing but a mutual exclusion which is going to be used for accrue and release the lock. And empty is a counting semaphore which will be having the count of how many empty buffers are there inside the overall buffer. So initially the empty will be number of slots there in the buffer. The next semaphore, counting semaphore, which is full, which contains the count of how many buffers are having the data inside it. That means that how many buffers are full. So at initial value of full will be 0 because no value will be inserted at the beginning. So these are the semaphores are going to be used for framing the solution for bounded buffer problem. So this is solution we framed for the bounded buffer problem. The first goes for producer. So here, in this example you can see here the number of slot is 6. So initially the empty value is 6 and full will be 0. So the first thing in the producer is wait empty, which means that you are going to check for the empty value. As we saw the constraint previously, if at least one buffer is empty only, the producer can insert a value. So if it is empty is 0, you are going to wait until empty is greater than 0. Or suppose if the empty is greater than 0, you are going to decrement the empty by 1 and then you are going to insert a data inside the buffer. So to insert the data, you are going to get a lock, that is wait mutex, which is going to accrue the lock. Why? Because at the same time producer and consumer should not work parallelly. So you are going to get the lock for the buffer and then you are going to add the data to the buffer. Once you added the data to the buffer, you are going to release the lock, which means that I have done with my job, so other one can use the buffer. So you are going to release the lock. And then you are going to increment the full value. So signal full means you are going to increment the full value because initially the full value is 0, but now I have inserted one value, so the full will be incremented by 1. So now the full value will be 1. So this is how the producer solution goes. The next one is consumer. Here the first thing you are going to check is for full. The constraint is if the if the buffer is full, buffer value is, if the overall full value will be 6, it means that no other buffer is free. In that case, sorry, if the full value is greater than 0, it means that there is a data present inside the buffer. So consumer can retrieve or remove data from the buffer. So you're going to check for whether the full value is greater than 0 or not. If it is greater than 0, you will be okay to remove the data. So you're going to decrement the full. So for example, full value is 6. You're going to remove one data, the full value becomes 5. So you're going to decrement by 1. After that, wait mutex. So if the consumer is going to remove a data, at the same time producer should not work, so that you're going to accrue a log using wait mutex. So once you got the log, you're going to remove data from the buffer. Once you're done with your job, you're going to release the log by using signal mutex. And then finally, you're going to increment the empty value by 1. So now the empty becomes incremented by 1 because one data is removed from the buffer. So you are going with signal empty. So this is how the solution will be framed for producer consumer problem using the semaphores. Thank you.